Well, we said last time that we're going to solve equations where the variable is an exponent by taking logs of both sides of the equations and then solving for x. It's going to work fine in these. What kind of log do you want to use? Ordinarily, it doesn't really matter what kind of log you use, but you accept that you want to be able to evaluate at the end. And if your calculator only has base 10 and natural logs, then you want to use base 10 and natural logs as your log. And then you have to decide between those two. If the base is already exponential, like this one is here, the exponential function, then it makes sense to use the natural log as the log you use on both sides of the equation. So seeing that e there tells me I'm going to use a base e logarithm. I'm just going to write down log of e to the 3t is log of 700, like that. And then these two functions are inverses. So log of e to the something is just the something. So I get 3t is log of 700. And t is log of 700 over 3, like that. And then you can put that in your calculator and get a 2.184. Nice. So that was convenient because these two functions just kind of cancel each other out. Here I don't have any bases that look like tan or e, so I'll just use the common log for that. Just do log of a half and log of 5 to the x. Then we'll pull out some of our exponent rules, things like that. I'm going to write this minus log 2, why not? X log 5, just because. You can, and then solve that for x by dividing by log 5. X is minus log 2 over log 5. Okay. And then I'm going to just do that right now. First of all, to get minus log 2, you have to type this little tiny minus sign that's down here. You can't use the subtraction symbol. It just doesn't work out well on most calculators. So I did that, minus, and then do log of 2. I'm going to close the parentheses because I'm going to be dividing by log of 5. I don't see my log over here, hang on. Other stuff must be there. Clear this out, try it again. Minus log of 2 divided by log of 5. All right? Minus 0.43 x equals minus 0.4306 and change 76 and so on. 0.43. I don't quite believe that. I'm going to check it out. I'll clear this out. I'm going to take 5 and raise it to the, now that minus sign again, a little baby minus sign, 0.43067. And I get a half. It checks out. All right, cool. Let's go ahead and solve this thing here. Here, we can just use base 10 logs again. Log 5 to the x, log 3 to the 4 plus x. So it's x log 5 is 4 plus x log 3. Okay, and that is 4 log 3 plus x log 3, like that. Why did I expand it out? I want to get everything with x on one side, so I'm going to take this x log 3 and subtract it off from both sides. So I get x log 5 minus x log 3 is 4 log 3. And then we'll factor the x out. That's why I stuck the terms with x on the same side, so I can factor the x out. Log of 5 minus log of 3. That's 4 log 3. And then we can solve for x. X is divided by that. 4 log 3 over log 5 minus log 3. And then put that in our calculator. 8.603, be careful of the parentheses you need around the whole denominator, not to mention other parentheses that might be around. And finally, we've got 2 to the x is 43. I'll just pick up common logs. So try natural log. Natural log 2 to the x, natural log 43, x log 2, log 43, x is log of 43 over log 2. Let me check that one out. Here we go. Clear this out. Natural log 43, close parentheses, divided by natural log 2, close parentheses. Go. 5.42626 and change. All right, so that was a quick and dirty exposure to solving equations where the variable is an exponent by taking logs of both sides. We didn't run into anything serious. Well, maybe this was slightly serious over here. There you go. Good hunting on the rest of 10.6. I'll see you in a few minutes. Here we go.